The moment the sun finally moved out of the way, the James Webb Space Telescope locked onto something no one was prepared for. The interstellar object 3I/Atlas had returned, but this time it was blazing at more than 400% of its previous brightness, as if it had switched on a hidden engine of light. Webb recorded a glow that didn't act like dust or frozen gas. It moved in smooth, intentional waves, as if the surface was adjusting itself to the heat. When astronomers sharpened the images, a new shape rose beneath the reflective layer. Perfect hexagons aligned in a metallic grid, a pattern far too clean for anything drifting through deep space. And before anyone could process that discovery, another signal appeared. A faint ultraviolet flash pulsed every 247 seconds with a level of timing that felt closer to a coded transmission than to any natural cycle. None of this fits the profile of a comet. So if 3I/Atlas came back glowing harder, sharper, and more controlled than ever, one question now hangs over everything. Why did it return at all? Long before 3I/Atlas burst back into view, it had already earned a place in the mysterious history of interstellar visitors. Only two objects had ever crossed into our solar system before it. The first was Oumuamua in 2017, and the second was Borisov in 2019. When 3I/Atlas appeared, it became the third confirmed interstellar object humanity had ever seen.
This coordination wasn't routine. Astronomers don't normally follow a comet this closely unless something about it feels off. And with 3I/Atlas, that unease began almost immediately. Its orbit didn't behave like a normal comet. Its brightness changed in ways models couldn't fully explain. Nothing about its path matched the graceful arcs we see. Instead, its course looked sharper, like it was responding to forces that weren't in the textbooks. And then, just as the data started hinting at a deeper puzzle, 3I/Atlas vanished behind the sun. All anyone could do was wait. When 3I/Atlas finally emerged, the first numbers that came in stunned every team watching. Its reflected light had jumped more than 400%. Natural comets brighten when they heat up, but they don't suddenly turn into cosmic mirrors. Yet that was exactly what the James Webb readings seemed to show. The object wasn't just brighter, it was reflecting light as if its surface had been polished or reconfigured during the months it spent hidden. As analysts compared the data, something even stranger appeared. The surface temperature of 3I/Atlas held steady. It didn't climb the way a normal comet would. Instead, it behaved like a system that was actively managing heat, keeping itself within a controlled range no matter where it moved. For astronomers used to watching comets flare unpredictably, this kind of stability felt deeply wrong. The brightness would rise and fall in smooth transitions, not chaotic bursts. The reflective layer responded to sunlight in a way that reminded some researchers of adjustable panels. It was almost like watching a machine regulate its exposure.
Natural comets build long tails that stretch away from the sunlight as dust and gas get pushed outward by solar radiation. It is one of the most predictable behaviors in the solar system. But with 3I/Atlas, the universe refused to follow its own rules. Instead of trailing behind it, the stream of material pointed directly toward the sun. It was a clean, narrow anti-tail forming in the one direction no comet tail should ever go. At first, researchers wondered if it was an illusion. But when data from the Hubble Space Telescope arrived, it showed the same forward-streaming plume. Keck Observatory in Hawaii confirmed the identical direction. Every telescope saw the same impossible orientation. The anti-tail did not drift or waver. It held a surprisingly stable line toward the sun, as if guided by a force stronger than radiation pressure. Natural gas jets do not behave this way. The plume from 3I/Atlas looked almost anchored, like it was reacting to an internal push. The behavior required something that overpowered the sun's influence, something that pushed material outward with deliberate force. A tail that flows toward the sun instead of away from it hints at one thing: a directed force coming from the object itself. When the first spectral readings were processed, the numbers looked nothing like a comet from our solar system. The light coming off its surface carried a fingerprint that was far too clean. Instead of the usual chaotic blend of rock, dust, and ice, the spectrum showed a striking concentration of nickel and iron in a form far more refined than anyone expected. Natural comets can contain these metals, but never in such purity. Then came the second surprise. Cyanide compounds appeared in the readings. Their presence is so rare in interstellar dust that many astronomers ran the tests twice. Yet the signature stayed. But the strangest clue came from the light curve. Instead of moving in messy spikes, the brightness pulsed in a rhythm too smooth for a solid body. The changes hinted at something hollow, as if light was bouncing through internal chambers. Natural comets are dense, uneven clumps. They do not allow light to resonate within a shell.
As teams calculated the object's mass, the results deepened the mystery. For an object its size, the mass was shockingly low. It moved like something far lighter than a solid core. The numbers lined up more closely with an empty structure than a filled one, suggesting 3I/Atlas was built around a cavity, not a solid nucleus. That possibility unsettled many researchers because it implied engineering, not geology. When 3I/Atlas came back into view, one small observatory in Spain captured a sequence of 159 consecutive frames. When stitched together, a pattern emerged. A narrow jet streamed from the side of the object, firing in a single, unwavering direction. It didn't wobble. It didn't blossom into dust clouds. Instead, it held a sharp, needle-like shape across all 159 frames, as if releasing material in a controlled burst. To astronomers, this looked unnatural. Comet jets sputter and scatter in wide plumes. They do not form straight beams locked into a precise heading. Yet the footage showed a jet that behaved less like escaping gas and more like thrust from a guidance system. With each burst, the trajectory of 3I/Atlas shifted slightly, not randomly, but with small, smooth corrections that looked eerily similar to spacecraft performing course adjustments. This was the moment the conversation changed. Maybe 3I/Atlas wasn't just moving. Maybe it was steering.
For months, astronomers had tracked it, but the moment it slipped behind the sun, all observations ended. This was the one place in the solar system where an object could change direction or alter its structure without anyone being able to watch. The sun's glare was the perfect cover. Not a single telescope on Earth detected even a stray photon. The space where 3I/Atlas should have been was a void. Then, just as quietly as it had disappeared, 3I/Atlas returned. The first images after conjunction stunned the teams. The brightness was no longer the same. The structure looked sharper, more defined, and the narrow jets appeared stronger, firing in a new pattern. It was clear that the object that went behind the sun was not the same object that came out. Something had happened in the quiet. What they did not expect was a signal. The object began emitting ultraviolet flashes at perfectly timed intervals, repeating every 247 seconds without drifting even a fraction of a second. Natural objects flicker. They never keep time like a metronome. 3I/Atlas pulsed with the precision of a machine. When the data was processed, the pattern revealed something astonishing. The first flashes mapped directly onto the sequence of prime numbers, 2, 3, 5, 7, 11, and onward. This was not noise. It was a mathematical signature. Prime numbers are universal. In the search for extraterrestrial intelligence, they are considered one of the clearest ways a civilization might announce its presence.
But the signal didn't stop there. The final burst stretched on for 13 minutes and 37 seconds. When scientists converted the wavelength variations into data,
The pattern formed a spiral. Not just any spiral, but one aligned with the golden ratio. Embedded inside were binary markers repeating in loops that looked intentional. SETI researchers immediately recognized the implications. A sequence of prime numbers is one thing, but a binary spiral keyed to the golden ratio is something else. It matches the very templates SETI uses when teaching what a deliberate extraterrestrial message might look like. When the ultraviolet signal finally faded, the object made one final move. Its trajectory shifted by a tiny but undeniable 0.09 degrees. For an object with no engines, the maneuver was impossible to ignore. Moments later, its speed began to climb. Not gradually, but in a clean, accelerating curve that sent it outward faster than the models allowed. The readings left one conclusion. 3I Atlas was leaving the solar system with intention, moving as though it had completed whatever purpose brought it here. It appeared, revealed pieces of itself step by step, transmitted something that looked mathematical, and then, without waiting for a response, pivoted toward interstellar space and vanished.